Sky This Month with your host, Dave McDonald.
Hello and welcome to the Sky This Month. I'm your host, Dave McDonald, and this is August 2023. And as usual, every month hosts wonderful celestial delights in the sky, and August is no exception, with a key feature every August in the summertime is the Perseid meteor shower, and we'll be talking about that in just a moment. But Venus is on its way out of sight. It is going to be in a position we call inferior conjunction, so it's basically between Earth and the Sun, and it will be emerging in the morning sky later at the end of the month, beginning of September. You'll be able to find it in the morning sky. Mercury is making its way out of sight, but the first week of August is the sweet spot to find Mercury, and we'll talk a little bit more about that at the end of the show. But keep in mind, to find Mercury, you need a good low western horizon without trees or barns or hills in the way. So you may have to consider where to go. And before I forget, let me encourage everybody to buy a decent pair of binoculars. Not $39.95 binoculars, but spend at least $80 or more, and you can spend a lot more, but $80 to $100, so you get a decent pair of binoculars, 7x, right, 7 power, 50 millimeter objective lenses is good. You don't be power hungry. If you want to go 8x, okay, but don't go more than 8 times, because the magnification not only magnifies the object you're looking at, but it also magnifies your shakiness, any movements, wind, etc. So 7x, 50 millimeter is the sweet spot. But again, don't get a toy, get something $80 to $100. And this will be an investment that you won't regret. It'll be years and years and years of use for the family. Don't think that you are going to replace binoculars with a telescope. Sure, get a telescope if you don't have one, but the binoculars are definitely allow you to see great things in great ways. And one of them is going to be to find the planet Mercury. And as a matter of fact, now find the planet Mars, because Mars is so far away as Earth moves away from Mars. It gets smaller, and also because of the relationship of Mars, the Sun, and Earth, Mars is also disappearing into the glare of the Sun. So very difficult to find, but binoculars will do the trick for both Mars and Mercury. And as I said, Venus will show up the end of August, beginning of September in the morning sky. But the good news is Jupiter and Saturn are returning to the evening sky. And as a matter of fact, Saturn is going to be in a position we call opposition, and that's a good thing actually. Saturn is going to be in opposition on August 27th. And that is like the prime night, if you will, to see it. But it's good, you know, a couple, 3 weeks on either side of August 27th, and it's good for some time to come. That is just the moment or the date of opposition. And what does that mean? That means that Saturn is exactly opposite the Sun. So when the Sun sets, Saturn rises. Sun sets, Saturn rises. We have opposition. And if you remember our talk about the angular measurements of diameter in terms of seconds and minutes, and when we're talking about planets, we're talking seconds of arc. Saturn is sporting a disk itself of the planet, 19 seconds of arc. And then if you include the ring system, you're going to be looking at 43 seconds of arc. So more than twice the diameter of the actual planet itself is what the diameter of the rings is going to be. So that's a good size for you to enjoy looking at your telescope. And just while we're mentioning seconds and minutes of arc, the moon, if you look at a full moon, you're looking at 30 minutes, roughly. 30 minutes of arc, or about a half a degree. There are 60 minutes of arc in 1 degree. There are 60 seconds of arc in 1 minute of arc. So that means there's 3,600 seconds of arc in 1 degree. So when we talk about things like 19 seconds of arc for the diameter of the planet Saturn, that's not a lot, but very observable in a small telescope. So that's just a little bit of information relative to that. So Jupiter also is going to be rising after Saturn. Saturn will be up around 9:30 over the horizon, obviously, looking towards the east. And we're going to tell you a little bit more about that a little later on. And then just a look ahead to next month, September, we're going to be talking, of course, about the equinox, the autumnal equinox, which will be September 23rd. And I had a wonderful family trip to Europe a couple weeks ago as of this recording, and I got to go to Stonehenge. So what does Stonehenge and September 23rd have in common? Well, stay tuned. And then the Andromeda Galaxy will be posing itself. We'll be taking a closer look at that next month during September as well. But as I mentioned at the top of the show, the big deal this month is the Perseid meteor shower. And it's not necessarily the biggest or the best meteor shower during the year. You have the Leonid meteor shower, and then early in the winter you have the Geminids. Great meteor showers, but the Perseid seems to be the favorite because it's summertime, and hopefully it's nice and warm, but we can have cold nights as well. And the good news for this year is the moon is not going to be a contender for attention, if you will. So let's just talk about, well, what are meteors anyway? So are they falling stars? You've heard that phrase. Oh, there's a shooting star. There's a falling star. No, stars don't shoot. Stars don't fall. They explode. But meteors are really small grains of dust and debris from the early stages of our solar system's development, and they are often bits of debris of comets that are in orbit around the sun, and every now and again Earth travels through the debris trail of a comet. And the word meteor is from the Greek word meteoron, which means a phenomenon in the sky. Because can you imagine, before people had any idea what these things were, to see all these things shooting through the sky? Maybe they thought the sky is falling. Well, 3 words that we want to pay attention to here, just to make a distinction. There are meteoroids, and meteoroids are the dust and the debris that is, in fact, floating around in our solar system. So it's the material that's up in space and staying in space, meteoroids. Then there are meteors, and the meteors are meteoroids that have collided with our atmosphere. And when they collide with our atmosphere, they burn up, and we see the streak of light. So meteors interact with our atmosphere. Now, a meteorite, these are the meteoroids that are big enough to actually land on Earth. So we see them as meteors streaking through the sky, but if they're big enough and they don't burn up, they land on Earth, and we have a meteorite. Now, just so you know, as many of you are watching from New Hampshire, But there are a few states, and you can look them up. And New Hampshire is one state where no meteorite has been found. We've had a lot of people, for example, come to the McAuliffe Shepherd Discovery Center with their rocks, with their specimens, and to have us take a look at it, and we find that they are meteorons, not meteorites. So, to date, no meteorites found in New Hampshire. So, let's just talk about why do we, they're up really high. They're up, 60 plus miles up in the atmosphere. And as we already said, they're the size of a grain of sand. They're really small. A marble size would create a fireball. So most are about the size of a grain of sand or so. Why the bright light? Well, it has to do with the ram pressure. And these meteors are hitting the atmosphere at 25,000 miles an hour. Those are the slow ones. To 160 miles an hour, 160,000 miles an hour. And so with that great speed hitting our atmosphere, it just creates this ram pressure that causes this flare-up of energy, and we see the light. And depending upon how big and how fast and where it's happening, it may be a short little wisp, or it may be a significant long-trailed meteor, or it could be, again, a meteorite. If it's big enough, it'll be bright enough and will land. So that's kind of the dynamo, the dynamics of why we see what we see when a meteor goes through and slices through our atmosphere. So here's a few photos, and maybe we can do this full screen. So as you look at the upper left, you can see a meteor going right here, and you have some going over this way. And if you trace them backwards, you notice that they seem to come from a similar point. Same thing upper right. Take a peek at that, all these meteors. And if you were to trace all these meteors, they seem to be coming from about where my red dot is. Would you agree? That's called the radiant. So meteors don't just streak across the sky. They come from a known point in space. And that's where the name of the meteor shower comes from. Now, in the bottom left, you can see we've got something coming back here, this way, this way, this way. So again, perhaps coming from around here, from a point called the radiant. It's the point where the meteors seem to radiate from. And in the bottom right around here, you see the same thing. Now this radiant point, I'm going to show you a little later where the radiant point for the Perseid meteor shower is. The radiant doesn't have to be above the horizon, but if the radiant point is above the horizon, you have a better shot at seeing more meteors, because you will be able to see meteors coming from 360 degrees all around that radiant point. Make sense? But before the radiant rises, you can still see plenty of meteors that may be coming at least from, let's say, 180 degrees from the radiant point. So the comet that causes the Perseids is the comet Swift-Tuttle. Swift-Tuttle. Tempel-Tuttle causes the Leonids. Swift-Tuttle causes the Perseids. And what you see here, if you can follow my laser dot, you see this is Earth going around the sun in July, the month of July, the month of August, September, etc. That's the orbit of Earth around the sun. And this here that I'm swooping through is the orbit of Swift-Tuttle, comet 109P, Swift-Tuttle, and that's the orbit that goes down and around the sun also. So the debris trail is right here. So every August 12th to 13th, Earth passes through that debris trail left by comet Swift-Tuttle. And that's why we have a predictable meteor shower. And sometimes we're able to predict, well, how thick is the debris trail going to be this year that we pass through? Is the moon going to be out? There are several factors that have to do with how many meteors we may see and how bright they might be. But this year looks to be pretty good. You may possibly see, on average, as many as a meteor a minute, 60 meteors in an hour. But that's when the radiant is above the horizon. And I'm going to show you a little later what 1 o'clock in the morning looks like. Now, for the little ones, you want to go out at 10 o'clock at night. It needs to be dark. 10 o'clock at night or so, you'll see some, undoubtedly. But the majority of meteors are going to be in the 1 or 2 hours before dawn. Because what happens is Earth, which is a sphere, is pointing in the direction of this debris trail. So as Earth is moving around in its orbit, it is going to be moving towards that debris trail after midnight. See, before midnight, it's like the meteors have to catch up. So if you can kind of think about your car in the winter, and it's snowing, all right? It's snowing, you have your headlights on at night, the car behind you has his or her headlights on at night. So if you look out the back window, you see some snowflakes. But if you look out the front, and you particularly you put your high beams on, you just see all these snowflakes coming at your windshield. And it's kind of that idea after midnight with meteors, because those grains of sand that are hitting the atmosphere, we are plowing through that happening after midnight and the hour or two before dawn. So that's a little tip on that. Now, we mentioned radiant, and so here you see the constellation of Perseus, and I'm going to show you a little later exactly how to find the constellation of Perseus, which rises 11 o'clock to midnight or so. And then the constellation of Cassiopeia, this W shape, you're very familiar with, I would imagine, in the sky. It's the queen of Ethiopia, Cassiopeia. And you'll notice where the radiant is, okay? So it's in the boundary of the constellation of Perseus. That's why we call them the Perseids. But it gives you an idea of how to locate it. Now, to me, the constellation of Perseus, if you use stick figures, looks kind of like a wishbone to me. And as you go up, just to the top of the piece that somebody's going to get to hold, and to the left is where the radiant is. You don't have to know exactly where it is, but that's the area of sky that when it's above the horizon is going to give you the best looks for meteors. Okay, so here we see a shot, and once again, if you look, you can see how if you trace these meteors backwards, they seem to be coming from someplace around here. But every now and again, you may have a meteor that does something different and seems to come from some other place or end up some other place. And that's just called a sporadic, because there are meteors on any given night. You could see 1 or 2 or 3. But these all seem to be related to the meteor shower with the radiant roughly about there. And so here you have the Big Dipper down here, and then this is just some meteors that seem to be streaking from a point to the upper left of the screen. So pretty cool. And just while we're talking about it, because the Big Dipper is overhead, and the Big Dipper is everybody's favorite go-to, but you can't quite see it here in this image, but I'm circling the middle star of the handle of the Big Dipper, and there's actually 2 stars there, and you can see them with the unaided eye. So while you're out looking for Perseid meteors, or any night for that matter, look to that middle star of the handle of the Big Dipper. You can see the Big Dipper here, and notice, by George, there are 2 stars there. There's actually more than 2. Get a telescope. Binoculars, bam, it's right there in front of you. Now, this is the Leonid meteor shower in November, but I just wanted to show you this picture because this is a view from above, from up in space. So kind of cool how you can see what happens when they hit the surface of the atmosphere. So, important, dress warm. Plan to stay out for a couple hours. Get a lawn chair. Drink a lot of water. Have some fluids handy, some cookies, some donuts, a tarp, lounge chair, sleeping bag. Look up and enjoy. Log the event. And if you're too near city lights or your neighbors, keep the floodlights on. Move if you can. Or call your neighbor and ask them to turn the lights out. So here's the well-dressed meteor in a nice warm coat, sweatshirt, sleeping bag, camera, local cows, your observing bag, you got your donuts, hot coffee, bug spray perhaps might be worth having handy, radio, cassette, you probably just have your phone and your earbuds these days, but enjoy yourself, and it's going to be great. So late night, August 12th, late night, 9, 10, 11 o'clock, and then better after midnight, August 13th, after midnight, and the best time again is the hour or two before dawn when the radiant is nice and high. And we're going to talk about where the radiant can be found, but in a moment we're going to just transition and I'm going to show you where to find Mars and Mercury and other planets and other stars and constellations. Stay tuned. All righty, so now Mercury and Mars. Get the binoculars. So the first week of August, it's not going to make a whole lot of difference, but if you can see here, Mercury really close to the horizon. It's brighter than Mars, so Mars, even though it's higher away from the sun, is going to be tough to find because it's not as bright. So you've got the first week in August to be hunting for the planet Mercury, and I wish you good success. Next, I want to talk about Jupiter. So here we are, we're late at night, about 1 o'clock in the morning to be exact. And so here's the planet Jupiter. This is looking east. So it's going to be the brightest object you find in the eastern sky. But the other reason I want to go to 1 o'clock, this happens to be on August 13th. And remember, what do we have? We have the constellation of Perseus. You see that wishbone? So right here, this is like the piece that everybody wants to hold. And you can see it's like maybe an upside down Y, if you will. And just up to the left is where the radiant of the Perseus is. And up just off the screen is that constellation of Cassiopeia, the W. Okay, next. When you find Cassiopeia, which is easy, it's that W shape. A bonus is if you take the middle star and you come out along that obtuse angle, the angle that's greater than 90 degrees, and you make a straight line, you're going to come to the double cluster, which you can just make out with the unaided eye. Guess what's going to help you? That's right, binoculars. Okay, so bonus, the double cluster's there for you. Next, just going back to find where is Perseus. We're looking east, and it is about 1 o'clock in the morning. So this is going to tend to rise higher and higher in the sky as the night goes on. But you can see Perseus, that wishbone shape. He is the hero. Maybe we'll talk a little bit more about the mythology next month during September. Okay, next, let's take a peek here. And now we're looking at the planet Saturn. So remember, Saturn is in a position we call opposition on August 27th, which means on August 27th, when the sun sets, Saturn will rise. But now, at the beginning of the month, after 9:30, it's going to rise. Here we are, mid-month, and we're around 11 o'clock or so at night. So Saturn readily visible. And maybe you notice here is the great square of Pegasus. Okay, and so it's a very easy to find asterism as you look east. And as you come down through these two stars, you come down to a star called Fomalhaut. And if we can go to the next slide, Fomalhaut is a star in the constellation of Pisces Australis, or the southern fish. But Saturn, easy enough for you to find. Next, we're going to take a look at what we call the summer triangle. And there are several stars that are involved in the summer triangle. 3, I guess, would make a good vertex for it. So Deneb is the top of the Northern Cross. We have Vega, which is the brightest star in the summer sky, and it's in an overhead position all month. And then Altair, we have a small star on either side of Altair. Next slide, you can see, connect the dots, if you will, the Northern Cross here. And you can see, if you can picture some strings here going between these stars that make up this parallelogram to make up a harp. And down here is the eye of the eagle. Next, we'll bring up the artwork, and you can see the Northern Cross becomes a swan, Cygnus the swan. We have the 2 wings on either side. The head is a star called Albireo. Telescopes will show it to be a blue and gold pair. And Deneb is the tail of the swan. Vega, again, the brightest star in Lyra. And then we have the brightest star in Aquila or Aquia, the eagle, and those 3 stars, each from a different constellation, make up the summer triangle. So next slide, your job is to go out and find it yourself, because I've pushed the magic button. There's no more artwork, there's no more lines in the sky. It's up to you. But you'll find Vega, brightest star in the overhead position, and I think you'll find Vega. The cross asterism shows up very nicely, and Altair easy to find with the 2 stars on either side of it. So that's the sky this month for August. Get out and enjoy it. It's the greatest show on earth, and you can find it in your backyard. I'm Dave McDonald for the sky this month.